Okay, in this video we're going to have a look at how we form the ionic equation for neutralisation. So here we've got an example. We have got hydrochloric acid that's going to react with potassium hydroxide. So the key points here to notice is that this is hydrochloric acid, and this means that we're going to make a chloride salt, with the first name of the salt coming from the alkali, so in this case potassium. So the salt is going to be potassium chloride in this neutralization reaction, and we always get a salt and then water as our second product. If we put some formulas in now for the symbol equation, so hydrochloric acid is HCl, potassium hydroxide is KOH, potassium chloride is KCl, and water is H2O. If you are unsure how I've done that, then have a watch one of the videos that shows you how to work out chemical formulas, and that'll take you through that step. So now we've got the equation. Hopefully we can see that it's a balanced equation already, so I don't need to do anything to this to balance it. Now in order to form the ionic equation from this, what I'm going to do is I'm going to split these chemicals into the ions that exist in the compounds. So here we've got HCl. HCl will split into hydrogen ions and chloride ions. Potassium hydroxide splits into potassium ions, which are positive ions, and hydroxide ions, which are negative ions. Potassium chloride is ionic, so that's going to form potassium ions and chloride ions. And water is covalent, so it doesn't actually form ions, it will remain as H2O. As I said, it's a covalent compound. Now what you should hopefully notice here is that we're looking for ions that have changed and ions that have stayed the same. So if I look at my chloride ion, I can see that it's a negative ion here, and on this side of the equation it's still a negative ion, so it hasn't changed. So what I'm going to do is I'm going to remove that from the equation because it hasn't changed, and therefore we call it a spectator ion. It's as if it's just watching what goes on. The next one on the list, let's look at this one. Here's my potassium ion, K+, and in the salt it is still K+. So I'm going to get rid of that K+, and that K+, because they are spectator ions. My hydrogen ion is here, and you can see it doesn't exist as a hydrogen ion over here. It's now formed water, so it has changed. So I'm going to leave that in the equation. Same for my hydroxide ion. It doesn't exist on this side, but it has formed water here, so it's changed. I'm going to leave that in the equation. So all I have left is a hydrogen ion plus a hydroxide ion and water. This is now the ionic equation for a neutralization reaction. Remember that your H+ ions, they come from acids. Your hydroxide ions, they come from alkalis. They're the sources of those ions in this reaction. So it's acid and alkali. We don't mix the salt, as we've seen, but we remove the salt from the equation because they are spectator ions, and we get the water left over.